is it working? I think this is working. I think I'm just gonna do the usual thing and say, are we live? Yes, we are live. Excellent connection, says YouTube. Let me just squeeze my Open Broadcast Studio to the left of the screen. I got sound, everything's fine. Let's go. Okay, so before I move on to a AQA, what's it called, Target Clear coding task from ZigZag, I just want to maybe disable my extensions, my AI. They don't use it. No, let's no comment on the GitHub Copilot. But before we start with some more ZigZag stuff, there's some really good chunky one that again are like, you know, the deeper you get into the document of the ZigZag task, the more unrealistic essentially the tasks become, because they're kind of like really far too large, and let alone, you know, even if they were specified properly, they would be too broad in scope to make accurate section D to be examined, you know, on the day in like, well, an hour 45 was, you know, it's for the whole thing, or 2 hours for the whole thing, but then you get a reduced, was it, no, it's 100, yeah, whatever. So the point is, but it's still worth doing them because you learn the code, right? And like that's how you work the thing. But there is this question that keeps coming up, and so Ethan, and he's not the only one, is asking, oh, how big it is on the stream. Let's zoom my browser, I'm zooming everything. Do you think in section D for Target Clear we could be asked to extend the program using OOP since the entire program has no OOP? If not, then how else can OOP be assessed in paper 1? Well, okay. You have a you know, whole world of discoveries ahead of you, Ethan, because if you, like OCR doesn't have a non-computer exam. So their paper 1 is on paper. They don't really have coding, but they have, you know, the kind of coding on paper like you do on some GCSE boards, and some A-level boards evidently. And so like, how do they evaluate OOP for that, right? You can get paper questions about OOP. In fact, it's actually easier to evaluate as a, you know, like it's the book, you have to learn the concepts and parrot what you've learned, than it is to evaluate as, well, you kind of get better results as a coding task, because OOP is kind of like broader in scope, and you're right, if there's no OOP in the thing. So let's have a look at Finalizing math tutor, which, I mean, already the order, that should really be maths and physics. Anyway, so if I look at the, even let's pick up an AQA level and have a little look. We're on paper 1, we would be in A-level paper 1, and that's in Fundamentals of Programming, the OOP, and Programming Paradigms. All right, let's have a look at Programming Paradigms question paper. There's also Programming question paper. I think those will only be the you know, paper questions rather than, oh god, I said, yeah, now Physics and Maths Tutor has decided to kind of put some advertising here. Now this time it's physics, last time it was biology. Still not really advertising the thing that people are going to be interested in. Right, past paper questions. Right, so that's how you can be, can anyone see? Zoom in. This is how you evaluate it on OOP, on paper 1 without section D, right? It's explain the relationships. Favor composition over inheritance is in their specification, and I mean, as a 1 marker, we'll have a look at the marker in a second, I'm curious about this. All right, so then you've got a class class of subclasses, you can have a 4 marker, so class definition on paper. Note that they're giving you this kind of like, you know, generic OOP syntax that, like Python doesn't look like that. They will accept Python code in your answer. You can write them in Python. However, some OOP concepts are kind of not really illustrated well in Python. Python is not a great language for OOP learning. Certainly for practice, yeah, sure. But like when you want to, you know, C++ or Java define their classes much more like this than what Python does, where you don't define the attributes on the class, it's just on the constructor. But the point is, right, you can write a class definition, so there's 4 marks, they expect that buyer, I mean, God knows, right, like they tell you what should be in buyer, presumably they also have a name and an address. Oh sorry, those are the 3 things. Right, so you've got 1 mark for like the correct definition syntax, and then 1 mark each for the attributes. And then relationships, aggregation, and composition, the difference between the two is, so 1 mark for each. Aggregation is when they exist separately, so you get the instances, but one refers to the other. Whereas composition is you call the constructor for it's not a subclass, but for like a smaller class, somewhere inside one of the methods of the larger class, meaning that if the larger object it disappears, so if you kind of dispose of the variable, don't use it anymore, also the smaller one doesn't. So aggregated, they exist separately, you stick them together. Composition is like you're making a composite, right? And so like your second one cannot exist with the first one because you create it inside the first one. So that's 2 marks, 1 for each. Client uses aggregation, and why it was considered more appropriate to use this type of relationship than composition. So client will refer to... I'm sorry, what? Oh, there's a location class. That's what they're talking about, right? So this one is identifying that aggregation is the location class. And as far as you know, like it's implied in here, you get a get address, but you don't have a set address. This location object that address refers to, that the address attribute of the client class refers to, exists independently of the instance of the client class. Therefore, it's aggregation. And it's more appropriate to use this type of relationship than composition because, think of it, you might, don't mention this in the answer, but like you can think of it as like a SQL where you want your entities to be separate so that they can exist independently from each other. The example here would be, we can have different clients that live at the same address, right? And so like the address shouldn't be, address object, the location object shouldn't be created in the code of the client instance. I'm gonna look at the mark scheme here because already, oh, it's in a different one, isn't it? Okay, boop. Sorry, I'm just doing this because like the tab I want is like right behind the webcam. Why is this, what's happening? This isn't what I want, past paper question, I want to past paper mark schemes. And we were in paradigms, right? So paradigms meaning kind of, I don't know if they get any functional in here that would be, mind you, I mean, surely laptop device, is there no object inherit? Oh, hello, yeah, right. So, well, typically, certainly when I teach OOP, that would be like your first term in year 12. And yeah, like when you're setting a test to your students and they just started in a loop, you've got like 45 minutes or whatever, you're not gonna put them into an IDE and ask them to code, right? So if you want them to kind of assess OOP, you use questions like this. You describe the problem and they've got to do a diagram. So you need to know a bit of UML notation, in particular all of the connectors, the difference between the inheritance connector and the two associations. So association, inheritance also an association. This is all general, anything you get a link. And then composition and aggregation are the one where like the empty diamond for aggregation, I'm pretty sure, yeah, no, it is, and the full diamond for composition. Right, my mark scheme for this was here. So that first one, this is da-da-da. Oh yes, composition over inheritance. With composition, it can be tested separately, but it's not possible to test a subclass and only for the base class. Composition can be an instant side effect for the classes when the base class is altered. Yes. I'm not sure that's true of both composition and inheritance. Composition is more flexible as if a new class composition. It really depends on, this is such a general principle that is kind of good, but like you really have to see a variety of examples. So when you get something obvious, like you get a vehicle class, and then out of this you make a car, obviously inheritance is that. What they're talking about is like, I've got an object, and say I want to also make it do stuff that live in another class. So functionally, it's not an inheritance as in it is a, right? So like a car is a vehicle, right? It's the subclass is a subclass, is child class of the parent class. But so Java, aside here, Java will make the distinction between inheritance and implementation. And implementation means I've got another class and I want to grab some stuff, your methods typically, interfaces, those are the things you implement from that class. And so you define them slightly differently to say it's like, it has a, or like has a side of it that is, rather than it is a. Let's look at the better one. Right, so this one had, yeah, 1 mark for the definition and then 1 mark each for the, oh no, actually, so set details and then extra free function for the reads and extra free variable. So there's 1 for all of the identifiers, 1 for the thing, and then 1 mark star star. So you know, it's 4, oh, it's 4, yeah, it's 4. Star star, I like star and star star. Acceptance then it gets separately that each variable is private or each method is public. Reject, do not award mark for declaring new functions if any of the function have the same names as the variable. Yeah, obviously. Or there's a Python as a decorator called add property that allows you to do a getter that you will actually access with a dot, like an attribute in old-fashioned OOP, but this could probably not, you know, I don't think at A level you'd have to worry about this. So this is all your thing, right? You get the problem and then you get to do all those things. This is how, in answer to even that, how else can be OOP assessed in paper 1. Now, could we be asked to extend the program using OOP? So there's a actually it's a Wikibooks task where someone, and I think that's probably a sign of the serious mental health crisis in this country, but someone has basically rewritten, see, it's dropped off of my internet history. That's how long I'm typing and speaking at the same time. That's how long I've not looked at the Wikibooks page, but someone did a task that was like, oh yeah, turn this is Treasure Island AS. I should do the AS level as well. I don't know when they sit it. But you know, it looks like it's a good way of getting a very specialized YouTube audience. And then they have a, what's the OOP one? Have I not seen an OOP task? Oh, make the program object-oriented. Yeah, okay. So, okay, it is very weird they haven't used OOP, but maybe just to get everyone to overthink about this so they can just like verify some basic programming, and also it's a chance for them to maybe have some regular expressions, because that's in the code, and that the reverse Polish notation, converting from one notation to another. So making the program object-oriented is a genuine, interesting problem, because in our code you've got right, so there's those 2 key things that could be each their own class or objects, which are the targets, which is the list of targets, and the available numbers. And if you collapse everything, there's my outline. This is useful in VS Code. Maybe just bigger. Even bigger. Okay, those are all the variables. So remove number used, that becomes a method of the number available. Update targets, that becomes a number all available. Checks number used are all in. Checks numbers used are all in what? Are all in numbers allowed, right? Used allowed, right? Okay. So yeah, that would be a, because it's a getter, right? You should try to verify. So we would pass the number used to numbers allowed. So you can refactor this and redesign this as OOP. There's really 2 good candidate classes for the target list and the available numbers, because each have operations you do that would make really nice encapsulated method. However, that's not going to happen because you cannot test refactoring. So if you ask the student to rewrite the code as OOP, there's no way that they can ask someone to test it with input and output saying that's been done the task correctly. All you can check is that you've not broken anything, and it means that students can fake the test by using running the old code and putting that as a test saying, oh, it worked as it used to be. So you'll never get a refactoring task. But that wasn't Ethan's question, who sensibly is probably twigged on this, he's kind of picked it up. Extend the program using OOP. And then, yeah, you could. But I'm really struggling, right? Because between Wikibooks and ZigZag, I think we get maybe a fairly decent selection of, what kind of legit, in the broadest sense of legit, you're not going to turn this into a dungeon crawler, right? It's how do you change and extend and modify the game in meaningful ways that are still small enough to be done in an exam, which isn't true for, definitely isn't true for some of the Wikibooks and then towards the end of the ZigZag task. Well, yeah, I'm really struggling to find, it is true, the answer, even to your question, is yes, you could have a task that would be create a new class, and, it should do this and that and that. Fair enough. And as we've seen in the question, there's the very video against which Ethan commented his. It's about the section D mark schemes. And in those, we've seen that you get some marks just for kind of like defining a class or defining a method or defining a function or, you know, maybe starting a loop, right? So like this kind of like the first couple of marks are not too difficult to get. So think tactically on Wednesday, the 11th of June, which is, how far is it? Days until, no. Here, no, still not that. What's happening? How far is the 11th of June? It's less than a month ago, less than a month hence. Days to 11th of June. 24 days, but I will be streaming every Sunday. I need to actually start scheduling them more than 2 days in advance, because in my head this is what I'm doing on Sunday mornings, but if people don't know, how can I expect them to log on and like and subscribe and stuff? So there's a bunch of Sundays until then, right? So there's today's the 18th, we also have the 25th, the 1st and the 7th. Right, so there's this Sunday and 3 more Sunday. I will be streaming every Sunday on this. We can have this be your Sunday morning appointment or ritual, as if I'm some kind of priest, and this is some kind of mass. So yes, we could be asked to put a brand new class in the code, and that would be a way of assessing OOP in section D, but equally, I mean, another thing, right, if you go and have a look at the past, so last year was Symbol Puzzle with the spiral thing, and Daston the year before, and all of those kind of previous ones, they were all written in OOP, but how many of those are tasks in section D that actually assessed OOP? You would change some OOP code, but like you're not, sometimes you get one, right? But you may get as well most ones. So don't overthink the OOP, but you know, technically it's possible. But you never get asked to refactor, and like the most obvious OOP thing to do is to refactor typically the, you know, targets and numbers and so on into their own classes, but that can't come up as a question because we can't test it. And then you could have something if it's a brand new class, but equally and it's seemingly Craig or Dave at ZigZag and the whole crowdsourcing, the whole crowd that crowdsourced all of that wiki books questions cannot seem to think of one either. So yeah, there was like 20 minutes to answer one question. That's very good. Okay, so I've put a Q&A in the chat. If you want to drop a question, I'd rather address your questions than just like code in a vacuum. However, so Solver, that's 19. It's like a full, I mean, it's 17, but you don't put, that's not 17, that's the previous one we did. Gosh darn it. The hint mode, where is it? I can't find it. The one I did probably last week. I'm sorry, this is all a blur now. 11, 16? This is the brackets. I'm not touching the brackets. I am not touching the brackets. Okay, there's the auto solver and hint? Clue? Helper, that was the one. So no. Yeah. No, this is the one with all the possibilities. Help mode, right, 11. Help mode, it was kind of like fun, but like find, you know, 2 to 3 operands up to 5 possible target. We don't need to display anything. So they call it brute forcing. Does not need to every possible combination, but obviously, because you're only going to do 30 attempts. It's not clear what an attempt is. I mean, we've seen the questions get. So it feels like 19, which is, I think, right, the full solver. Is actually the brute force. So if it tests all, that's what brute forcing is, right? Like, what do they call the first one brute force if you just kind of like weak brute? This is the full brute forcing. So it's not really a auto solve. I mean, it is a solver, sure, but I was expecting something that would reduce, rather than brute force trying to be a bit smart and figure out, am I getting closer to a target or farther away? So that would be one. Nah. Not mad about this one, but that's an option. The other one I was looking at was this one, except I misread it. So we can enter stuff straight in Postfix. But let's do this one to warm up, because I want to do something where you can enter stuff in Prefix. This is going to be fun. Because then, think about this, like there's no OOP, so what could you be assessed in? That's going to be scary. Definitely, maybe your notation conversion, because that's the core of the program, right? Can convert to RPN and evaluate in RPN. That might be something that comes up. So let's duplicate this one and rename it to T7. No, sorry, not T. Z. I should upload this to GitHub in case you want the code, but that would kind of defeat the educational purpose of those, wouldn't it? Boop. Okay. Postfix notation rather than infix. Should use the comma as delimiter. Okay, so I'm not even gonna enter the I'm not gonna give the user the option, because that's we can recognize them, right? We can kind of figure out, does it end, a postfix expression will always end by an operator. Therefore, you can smartly figure out, okay, enter an expression. I'll make the microphone under the keyboard. Crazy stuff is this. Let's go infix. Right, so this is one to intervene, because where we want to intervene. Checking user input is valid. We're going to need to add some stuff in here, because in so a postfix expression, right? Like an RPN expression, if I've got, say, okay, 12 times 5, all right? But if I write this in postfix, it's 12, 5, star. So I kind of need a delimiter, and they are saying we should use comma. This is what's expression intern using postfix notation. Use a comma as the delimiter between each element to allow elements to be correctly identified. What is great about this is that this is simplified so much. We'll see, right? We're not going to do any of that. We don't need to do the conversion to RPN because we have it in RPN. We just need to basically split a list. So here, this is a. So this is number. Oh, gosh darn it. Right, so that's an operand. And then there's an operator. So, this validates it with starts with an operand. This is going to be a nightmare. Okay, I'm going to do an elif in here. So this is the infix. Print arrow validated. Valid infix expression. I'm going to make my screen even bigger, if we can imagine such a thing. All right, whereas here, another close elif, and so we are going to do a regular expression search as well, but with a different regex, which is, if it's a postfix expression, so this will actually validate like operand operator. No, because there's plus, so there's one or more. No, is it the whole thing? No, so this whole thing is one or more. That's the plus here, right? So like this whole expression, which is an operand and operator, however many times, and then the final operator. So here we're going to have I can't validate it as smartly as this one, because this would kind of, I just say, right, this has got any number of this here, between the square brackets, this is our list of operators. And this bracket here is to say we repeat this. So I'm going to say it needs to end by an operator, before which it's going to have a literal comma, which I think should... And then it's going to have either operators or... Yeah, basically either operators or numbers, which is this whole thing, where like any number of... At least one combination of any number of thing, but it's the other way. No, because this is operator, this is number, operand, and then operator. Just let me build this. Okay, so we get the comma. So that looks. This is how that looks. Okay, I might need a piece of paper or whiteboard. Let's real quick. Right, let me see what I'm thinking about. So it ends with an operator. I'm going to say my operator is a plus, right? It has an operator, is going to have a comma, and then it's going to have either some more operators, potentially any number of times, or an operand, which would write in 99. And this itself can have a whole bunch more at the back of it. Right. So I mean, it will. I can do something that will validate invalid. It'll validate stuff that's not actually correct, but we'll cross that bridge very quick. So we'll end with an operator and a comma, and then before this, we have at least one, but also potentially any number of an operator, so a number, an operand, then an operator, and then that operator 0 or any number of times, and then that itself, this is not gonna work, is it? That has to be repeated one. Okay, so let's just do this and open a Python shell. Okay, that's not gonna work because we don't have we've not imported the regular expression package, and I'm going to say user input. Two plus 2. Okay, and then run this validation. Slightly bizarre. Oh, so is none means we've not find it, right? Yeah, because this is not is none. No. Look at the cat coming on the desk. So that's fine. It doesn't validate this one, but if I say user input is in fact equal to 2 plus or 22, so 2 plus shouldn't validate. That's also true. Remember, like true means is none. We will not find any substring of that kind in our string. 22 comma plus. That's false, so that's valid. 22 comma. That's also valid. And then if I've got like a bunch of also valid, I think I've got them kind of like, oh. So this is not gonna, this is obviously not that's correct postfix expression, but at least it vaguely looks like. Oh, true. Wait, false, true? Okay, so this one doesn't actually work. Because we've got this, and then we get one or more. Maybe I need some brackets? So let me put back, so, false means it's valid. So this one was valid, I was quite happy about this. This one isn't, and this one isn't either. So let's, now with brackets, is that none? It is none, because user input, well, this was like the garbage one. All right, so let's say this is, this is actually a legit one, 2 plus. That's my user input. Validate it. True. 2 plus doesn't pass this validation because it ends with this. It's get the comma. Oh, wait. I need. How do I make a? So I think I want something like. Something, okay. Comma. and then this group. So actually don't make that a group. I'm going to put them here. So that means, I think, there's an online regular expression checker that's helpful. We can work this one. So this means a digit one or more times, and then or a class. I might need to bracket those as well, or a class of, or you know, any of those. Remember, you get the escape as well that gives you the backslash. So it's this, but not this followed by that. I actually want this as an item, or that as an item. I'm losing track of my brackets here, it's critical. So start of the string is definitely going to start, it should start with a number. Then a literal comma. It should start with at least two numbers, right, presumably? Yeah, okay, so it should start with comma, another number. Yeah, I didn't foresee the validation was going to be the stinker. Oh no. Oh, that's right, because when you use the option, you just don't validate it. Oh, I got sight. Let me just finish this just to kind of see I can actually do it. Right, so it's a number, a comma, then a number, and then maybe optionally, then another, well, we get the comma here, right? So like that's our comma. And then optionally, I'm going to have potential, kind of any, so any number of times I could have an expression that would be either, can I just like, you know, change of plans. I'm going to ask for that last operator to be present one or more times, because of course, like it always ends with an operator, but we may have more than one because we may be evaluating more stuff. And I will always start it with a number and a literal comma, and then before that last operator, a literal comma as well, or those last operators. And then in between, this is not going to cater to every single expression though, and then in between, I'll start with a number, ends with one or more operator. Start with two number, actually, ends with one or more operator. But then in the middle, I should be able to accept either operators, which are, this is this, or digits. I don't have backslash D. I could use backslash D for digit, but, or, nah. I don't know if I can like bundle this as one thing and then have this as another. Actually, I don't need brackets here. Well, the brackets are for capture, but right. So I would have this. I would have number, comma, and then either, so like your square brackets in Regex are, oh, what have I done? No. Yeah, are for, you know, kind of this or that. So it's like a plus or a minus or a star or a slash. Don't worry too much about the double escape. And in that, I either have this, or, so I put it right next to it, runs. I bet it's not going to work. If it doesn't work, I'm just going to move on to something else because I'm not really good at regular expression, as we say. Now you have two problems. So maybe they won't ask you to do regex because it is so tricky. This expression, I believe, is a square bracket, meaning, you know, we could have an alternative of either an operator, which itself is kind of like a sub square bracket syntax, or operands, but it's one or the other, and this itself can be present 0 or more times. I remove the spaces because I don't need them in here, and I'm not sure. This is the first time I'm doing like round brackets inside square brackets. This might be a little bit too crazy for Python regular expressions, but who knows. Okay, so let's assume this working. We're going to print a valid postfix expression. But let me just check this. Up. Whoa! Unbalanced parenthesis. Okay. Yeah, we're not allowed to do this, I think. Well, maybe I don't need those, actually. But I do need those. Not confident about myself. Yes, okay. False, which is it's not none. Oh no, false. Is not none is false. So which means none is true, which means you couldn't find any, right? So that means not valid. So if I say user input is equal to, let's get my just very basic one, 2 plus, and our research, and that's still false. Okay, so you'd think, right, like operand, operator, operand, and then the commas and stuff. You know what? We're just gonna do the. We're gonna, you know, just kind of revert. Forget about they didn't ask us to do the validation, so we're not going to do the validation. Starting to try to be too clever and yeah, just having some fun. Let's do the thing. All right, so we are in play game. We have just accepted the user's thing. So this might be infix or postfix. There's a thing. Okay, so if comma in user input and ends with, yeah, ends with, another thing, ends with no. Not even ends with, because ends with is like a whole substring. There's like is there a substring, a suffix at the end of the string. What I want is the last element of user input, which is like minus. You kind of do it like that. Right? If you're on the end of a list in Python, you so L is equal to 1, 2, 3. With the brackets the right way around, it helps. If you want the last element of a list, it's -1. Boom. Right, so if the last element of a string, it's just an iterator. So if the last element of this is in a list of, do I have my operators anywhere? I can leave them for something. Ah, those have precedence. Yeah, here we go. So if I have there are commas in the user input and it ends with an operator, that's like an RPN expression. So we capitalizing the print. Yeah, so here I have an RPN expression. I'm going to print assuming RPN because we know it's got commas and we know it ends with an operator, but like whether it's going to be valid, we don't know. But just let's something. And so we just said user input in RPN is literally equal to the no, because convert to RPN. If you see, so it's just kind of boom. User input in RPN. This is practical. The old will return I'm pretty sure, a list. Convert to RPN will return the user input in RPN, and that comes out as append, right? Operators -1. The string operand, right? So that's like, that's a list of strings. So the integers are a string. So simply what we need to do is split it by comma, which you actually make a little string with the delimiter you want to split by, and then call the split method on this, and that then you pass the string you want to split, which is user input. Otherwise, we what's happening? Yeah, no, okay. There's no comma here, colon here. Elif. So if we don't have an RPN expression, I'm just if we don't have an RPN, I'm here, right? I don't have an RPN expression. Well, I don't have something I assumed was an RPN expression. I'm going to need to check if it's. I'm running it with the validation for infix expressions, and then I'm just falling through so I'm back to the regular code, but I'm slightly stuck in the I kind of feel like I want to move this back in, because, right, so that we kind of have we have a conditional that decides which user input and RPN we're going to have. But what's going to happen with the else of this? I guess the else is like you fill through the thing and you take the minus score of 1. So that should work, right? Well, not if I obviously don't have the conversion twice. Right, so input. I check whether it looks like an RPN string. If it's the case, I use this to split it. Otherwise, I'm just going it through the validation for infix and then converting the old way, so that when I land on this line, I have the user input and RPN, hopefully in the right format. Let's run it up the flagpole and see if it's oh, so I'm just on the, I'm on the live chat, I was on the question, sorry, I see Nepali man and section A and B. I can do a section B question. I don't know what's on section A this year. It's not going to be connected to... The section A is the stuff we've looked at, so you can get them on physics and math tutor. Section B is always fun, is this kind of self-contained 20 minutes to do a code thing. We can do one next week. Have a look, or I don't know, I'll make a video about it. Right, so I was here, I've put my breakpoint, I've got... Don't need... I was trying something earlier. Yeah, sometimes I rehearse a little bit because it's more complicated than it looks. Okay. Let's see if this is going to crash straight away. Right. Random game. Okay. Let's see if we've not broken anything. Let's put something that will work. 9 plus 1, 8 times 6, no, 8 times 7, 42, minus 1. That will work, right? 8 times 7, minus 1. Ooh, oh, those are old watch expressions. What do we have here? User input and user input in RPN is 87, right? 87 star 1 minus, right? So that I've kind of converted correctly and gone into the code, and then this is where I'm gonna what? That did not work. It's okay. Weird. Let me just put one here and do it again. You can change breakpoints on the fly when debugging. So 6 times 7 minus 1, because I think I've broken the is target. No, is target is true. Is target is true, right? Why have you? Oh, because I put 8.7. All right, I just okay, not paying enough attention. Too much going on at once. So infix still works, or does it? Right. Oh, I think I've just put an empty string in that's broken the code. Right, so I think infix still works. Let's try an actual RPN postfix. Yeah, so Q19, that was the plan. I was planning to do Q19 today, just kind of getting 17 out of the way. Or the other way around, I don't know. I think there's a more interesting one because I wanted to extend 17 first. All right, let's use the training game because at least I don't have to. We know the ones we love. There's a right. So I want to hit the 9. I'm going to do 8, 3 plus 2 minus. Right, 8 with the commas and a 3 plus 2 minus. Assuming RPN, so that's already kind of a good start. And then it's not. It's ooh. Evaluate RPN. User input in RPN is blank. Oh, that's fascinating. How do we get here? Check it. Go in there. Check in user evaluation to target, and in play game. That my breakpoint is now later. It has printed this, right? So I should have. This is surprisingly empty. Right. This is where I've got user input and RPN, and I should have gotten in from else. Valid infix. Pint. Print. Super. I've broken it. Absolutely. Yeah. Okay. Right. Unbelievable. You're in a whole bunch of old terminals. Okay. We're gonna the training game, please. 8, 3 plus takes me to 11. 2 minus plus comma 2 comma minus takes me back to 9, which is in here. Assuming RPN, we're all happy. I think am I not using split? Oh, so it's join. Sorry, join is this way. You put the delimiter. Sorry, I'm confusing myself. So join, you put the delimiter and then you say join this string. I was like, here it's split this list. You join this list, and then here it's user input dot split, and you split on the commas. All right, that's why it wasn't working. Gonna work this time. Promise. Bear with me on a second. 8, 3, comma, plus, comma, 2, minus, no comma at the end. Okay, we assume the RPN, very happy. Yes, right, the user input in RPN is correct. So if I continue, this is going to evaluate. Uh-oh. 8, 3, user input was that 3, and then it should put, what are we doing? You should have the plus in this stack somewhere. There should be an operators. That's not right. Shouldn't have that. Okay, so maybe it's not working as I thought it did. Again. So yeah, sorry, I will do Q19 later on. I'm sure I've been clear. I haven't done Q19, or we've not missed it in a couple of minutes. Because that's going to be a long one, Q19. Well, not as long as it's going to take to try and figure out all of the combinations, but who am I? I'm not the one designing those things. And a comma for this minus. Okay, right, so I'm starting to suspect I get some breakage here. No, that's correct, right? That's the actual RPN thing. So can I just move it, click it on to the next one? It's all good. They're all in numbers allowed. I want to go into check user target, evaluate RPN. This is where I'm going to want to have something inside the loop, I guess, right? Every click of the loop, a breakpoint, please. Boom. So we hit it first here. We have the user input RPN, still the same thing. 0 is not in there, so we're going to append it to the to S, the stack, which let's put a watch, add to watch. I don't want those, but I want this and maybe that. Okay, so and then we're populating this stack with, you know, the first operator, the first operand, the second operand. Poof, we've popped them and then sum them. 11.0, that's fine. We'll worry about the float and the type later on. Add the 2, and then we subtract. What's happened? We go in here, operand is free as a string, and then we had count operators. Why am I in convert to RBN? Sorry, maybe I do need to call stack. Oh, that's right. So remove number. Okay, yes, right. That's the problem. So there's another place that's yeah. Right, so this is an example of like we're actually learning things here, because although it's a pointless, you know, all tasks are pointless ultimately, but what we learn here is that actually there's another place that assumes we're going to use the user input again and going to assume it's an RPN. So we're not going to want that because remove number used. Okay, I'm literally just going to actually pass it the RPN because it has it already. Or does it do something about this or no? Okay, remove number used. We'll convert it to the RPN, and for each of those check that it's a number, and if it is, you remove it from the numbers allowed, and that's where you, yeah. So instead of taking user input, I'm going to put user input in RPN, which means I'm putting user input in RPN here, and I don't need to do this conversion anymore. It wasn't my fault. Well, it was my fault, obviously, but you know, at least there's no bug in the code. We'd forgotten that there's another place. Who knows? There might be a third place that expects this in infix 8, 3, 2, no, plus 2 minus. Okay, yes, right, that worked. Wow, cool. Okay, so that's 17 in an hour. I mean, you know, there was a lot of blah 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 at the top. I can't cut it and so on. 17. I might do it again as a special dedicated video. Let's have a look at the difference. Select for compare and Z17, and then compare with selected. The changes we've made and the friends we made along the way, right? We now are accept either. No, I'm not going to give it a choice. I'm going to figure out for myself, and then if I can give it a broken RPN expression that's going to break in the ugliest possible way, but like all of those things, you just assume everything is sanitized and good. So it looks like this. We've really changed around the time that's kind of like reading the user input so that we don't do this conversion. We get straight the user input in RPN, the key being to split it. So you do it the right way around. You take the string you want to split, and on this you call dot split the method, and then you pass the separator, not the other way around. The other way around is for join, to which you pass a list. So it's a string, the separator, but like it's not that, right? Okay, so we then get a string, assuming it's all valid. Fingers crossed, we get a list back that goes into user input RPN, but also I've changed it later on, haven't I? Here, now those are all marked because there's some, let me zoom out a little bit for this one, right? But because there's some indentation changes, so they're kind of all marked as change, but as you notice, it's not the same shade of red or green, right? And whereas this one has a proper green, meaning we've changed it. It used to be user input, now it's user input in RPN, meaning in remove number use, we don't need to do the conversion anymore. That was 17 regular. I'm going to now do 17 and a half. No. Okay, and I can put dots in file names. Okay, 17 and a half is the same thing, but prefix, check this out, prefix or infix or postfix. We want all of the fixes. So same deal, we've got this, we don't touch this. What we want now is just an elif. Again, not worried about the validation, right? We only do the validation for the infix, but we want an elif to validate that something is prefix. So it's literally just, it's the same, right? Like we have commas, there's commas, and, but this time it's not the last one, it's the first one. Print user input in RPN. And this is going to be a new function. I'm going to need to convert PN to RPN, or like convert prefix to, with a capital T, prefix to RPN, and we're converting the user input. That's all we need to do at a higher level. All we want is a helper function that's going to be convert prefix to RPN. Let's go, let's put it next to the conversion. Let's go above. Def convert. So it's going to take user input, and that's it. The output, like always, well, you can start with a list, you return a list. Magic happens. That's essentially the basic structure of our thing. Now, to convert from infix to like from prefix to, can I just do this on this? Would that work? Yeah, I think I did it like, boom. Okay. What we want to do, this is garbage. Yeah, okay, no, that will work. The stuff is going to come in with prefix, so it says the operators at the front. So let's say I've got plus with commas, 1 multiply 2 3. Right, so this will be, no, left to right. So that's actually, this is, we multiply 2 by 3. So this is 2, this is like, this is 2 by 3 plus 1. In human language, right, in infix. But to convert it, what we want to do is we want to flip it, reverse the list. So it becomes 3, 2, star, 1, plus, like this. And this is completely illegit. Right, yeah, my handwriting is terrible, that's why I use computers. So I told my year 2 teacher when they were teaching me to write. Right, so once I've got this, you can iterate over this, and the rule is, if it's an operator, you plonk it onto a stack. So that's going to go, you know, you kind of read through this, you get a stack S, and it starts empty. And then we're kind of making, so that's S, sorry, it should really kind of do it like, yeah. My stack here starts empty, you get the 3, you get the 2. And then if you read an operator, you, well, this is where you would kind of like pop them and execute, right? But like you would, do you actually? I'm not even sure now. So I went to Geeks for Geeks. Let's transition to this again, right? So I'll disclose my method, because this is what I was doing at the time. So because I worked on it a little bit before, it works like this. Here's what I made earlier, prefix to postfix. I can't even, it's like fairly straightforward, right? You get you recognize operators, you get a stack, you get an input. First you reverse it, which you can do 2 different ways. And then if they're an operator, you pop A and B and you append A and B and X to the output. Yeah, so you need the stack as an intermediate thing, because sometimes you just need to append the integer of X. The problem of appending this, actually there should be stack extend. Yeah, if I just do stack extend, I've done this kind of recursive flatten though, slightly unnecessary. All right, no, I've remembered. Fine. So the magic is like this. First, we reverse. So you can do user input There's a reverse function in Python that will do this on list. Another option is to use that notation, which is user input becomes equal to user input. So if you remember your kind of year 10 list stuff, I don't know how much you were, don't use them both, obviously, because you reverse twice, you get the same thing back. You know that we can get a single item from a list with the typical square bracket index notation. That's classic. What you may know as well is you can get a range of items with the column notation, but just like in range, you can actually also set parameters of iteration. So let's say give me from 1 to 300 but in steps of 7, and that would return a sublist that kind of selected from this. So because you get this, you could actually do something like, if the values were different, you could do from 100 to 3 in steps of 4, in steps of -4. That would work. So essentially, if you want to reverse a list, it's like if you leave the first two blank and then give me the list from the end to the beginning in steps of -1, and that's reversing the list. Anyway, we reverse the expression and then we iterate over it. So remember, at this stage, user input is it's not a string, or is it? Sorry. So user input comes in as a string. Make it a list. So the string will be comma separated. So we've just done this before. We're going to do user input. So user. I'm using this. No, I'm going to call it infix. Infix is equal to no, prefix actually. Sorry. Prefix becomes equal to the user input, which I need to spell correctly, split by the comma separator. Now we get a list. We reverse the list, reverse the expression. Now that we get this, we can do this. This would have worked, but it would have reversed it character by character, which means any kind of 2-digit number would have been, reverted. It's a whole nightmare. So now we can iterate for x for the element, because x we don't know at this stage if it's an operator or an operand, right? For x in user input. And the logic is if, okay, so if it's an operand, just add it to the stack. So we know stack S. But if it's an operator, so this is, let's just think about what we get in the stack, right? So we're reading the things backwards. So that we had, okay, so no, let me just encode, it's going to be simpler. So if it's an operator, pop the first two operands and add them in the operator to the output. It's a bit lengthy, but what I mean by this is, okay, so let's say our expression is, right, let's use a fancified one. This is the one I have here, plus 1 star, yes, it's prefix, 2, 3. That's prefix. Now we've split it, we've got, so it's all going to be kind of in quotes, right, because it's all individual characters, 1 star, 2, 3. So that's as a list. When the reversed expression, now we're getting, right, so from the backwards, it's 3. Okay, let's, I'm omitting the quotes for clarity, right? Actually, I'm not even delimiting that correctly. Omitting the quotes for clarity, we get 3, 2, start the thing backwards, right? 3, 2, I might start even omitting the commas, 1 plus, right? So it's kind of like, because we've reversed it, we will encounter, we read an operator only after we have read the operands that it's operating on, right? So like here, it's like star, because we're multiplying 2 and 3, but because it's reverse, we encounter, we kind of like reading, we're going through the list, it's 3, then 2, then the operator. So in our RPN, it needs to appear in the order in which we got it. And we like, so in the reverse Polish, the correct reverse Polish for this is, well, it's actually just that, to be fair, right? But sometimes you're gonna have brackets, and there's some logic in there that is there, because okay, what if it was, so I've not really done that right. This is actually better example would be this one, because you get consecutive operators. So now this is here, right? And then now this is, now we're talking, right? Now we get the 1 first. So here we're gonna have 1, then 3, then 2 go into the stack, and then the thing we want in the correct RPN for this, by the way. So we're coming in with this. We want the RPN expression for this, which is going to be 3 to, okay, like, you know, it's about the order more than the separator, right? We multiply, and then the last operation we do is 1 plus, right? You may have seen that you can represent them as trees, and you represent the expression as a tree, which is like the actual expression, and then depending on whether you do pre-order, in-order, or post-order traversal, what's outputting from the tree is the prefix, infix, or postfix expression. So nice bits when like different bits of the spec turn out to actually be connected, which I really like. This is what we're going for, right? So ultimately, this is not, because in the first case, this was, when you reverse the prefix, you get the postfix. Here, that's not the case, right? Because if we do this, that will do something wrong. This, well, actually will work, but like not in the same order. And so if this had been like a minus, you would have a problem. So what we want is, okay, we meet them, we put them to the stack. So we push. Then we pop the top 2 numbers. It's going to call them numbers with an operand. Add them and the op to the output. So in this order. So here I'm going to push 1, push 3, push 2. Then I'm going to pop. If I pop them, I'm popping 2. Then I'm popping 3. And that's how I want them. That's how I want them in this, right? Because like sometimes if it was a divide, this matters. At the moment, this doesn't matter. 2 times 3, 3 times 2, whatever. I should have used like asymmetrical, commutative operations, but that's the thing. So the point here is like we pop in the same order, right? So because like we're gonna, I can't even get it right. Pop 2, then pop 3, yes, and there should be 2 3 star because we established it. No, that should be 2 3 star, by the way, right? Because they came in that order. So yeah, right, fine. So if X in the list of operators, which I'm typing it by hand because I'm a big boy, minus the other one and the 4th one, this is where it gets a bit annoying. You might want to have a global variable or some kind of thing, because if you want support caret for exponentiation, whatever. But like let's stick with the basic for maps operator. So if it's, well, let's not do this is when we get, like, we're gonna have to have this comment here. This is the complicated part. Else, ellipsis, ellipsis. Okay, if it's an operator, we push it to the stack. So this one we know how to do. That would be s.append to the stack x. Right. So that's going to be here. It's going to be a equals s pop, b equal s pop. So I have in this instance popped one before the other. Like this is the thing I've been trying to work out from the beginning. So this is going to be push through, push 2, push 3, pop 3, pop 2. So it should be B, pop 3. I should do like the divide, but that would be easier. 2 and 3 means you want to multiply 2 by 3, obviously. It should be 2 3 star, maybe it's a bit like this at the bottom, like 2 comes at first. So this now 2 3 star. Yeah, sure, that's actually the right order, right? So what we want is an out extend. So append will add it as a new element to the list. Extend will extend the list by those things, those kind of merge two lists essentially, concatenate them if you will. And we extend that list by A, then B, then X, which is the operator, right? Confident about this, kinda, maybe. Put this here, and then raise the indent, and return out. I'm feeling lucky, let's go. Yeah, we don't need this. Okay, don't save. A training game, very much training day. The usual, 8 plus 3, right, so prefix. Well, actually this is the one I was doing, right, it's plus rather than minus, but, so prefix plus 8, 3, yeah, but then I can't, okay. Minus, plus, minus, comma, plus, I don't even know whether that's the thing I get, 8 and 3, so this should evaluate first, it gives me the 11, and then 11, and that's 11 minus, no, it's 8 and 2, right, no, it's 8 and 3, so 8 and 3, and then minus 2 to get to 9. Whoa! Oh yeah, because it's extend, you obviously want to be syntactically correct, so you extend, you call the function extend, then inside its brackets you pass the argument, the parameter, that is itself is a list that is bound by square brackets. So now that I know it's comma, minus comma, plus comma, 8 comma 3, comma 2, question mark. Okay, so it's still not working, well, because I've not saved it. Is that the problem now? Are we kind of, oh yeah, because if I run it from the console, it wasn't saved, so that's why. Again, minus, comma, plus, comma, 8, comma, 3, comma, 2. Could not convert string to float is interesting. Yeah, so it's trying to evaluate the RPN. Okay, I'm going to need I think I'm going to need a breakpoint, obviously. Also, then if we run it in debug, it will throw the exception and whatever. But assuming prefix, let's see what comes out. Before we call, this is where it breaks. Numbers allowed, we're fine. But this is where it breaks, so let's debug it from here. Debugging is the process of removing the bugs from the code. Do you know how the process of adding bugs in the code is called? It's called programming. Just waiting for the debugger to launch. Okay, now I can do this. Minus, comma, plus, comma, 8, comma 2. Assuming prefix, targets, we've got this, numbers allowed. S is not defined, which is fine. Kind of wanting the user input in RPM. Let's go put a watch on this, add to the watch. And that is, oh my god, I've got the commas in there. What? Okay, I think I've done the splits in my, it's past the display one for some obscure reason. Oh, yeah, no, sorry, duh. Yeah, the whole point of converting it to the list is actually, yeah, not the thing. So we get the list in prefix, we revert it, and then we iterate over it. Okay, so that's not even a genuine bug, just a kind of like not being fully awake when coding. All right. Third attempt, fourth attempt, and now I've done this so many times, it comes absolutely naturally. It's minus, plus, comma, 8, comma, 3, comma, 2, right? That's interesting. So S is empty. We're trying to pop when it's empty. Oh, because we can't. That's the thing I've forgotten. So we need to do the. We still need to do the dumb. Right. Okay. That's yeah. So sometimes you need to get it wrong. Sorry, it's kind of like wasting time, and I could have been a lot tighter. I might reshoot this as a video if I can be bothered. We don't want to go it straight in the out. What we want to do is actually push to the stack or its list of A, B, and X. Because what we have here, so this is, once we find an operator in the reversed prefix expression, that means it's time to evaluate. So we're not going to evaluate it, but we need to take the expression we've just had, which is a combination of 2 operands and 1 operator. Notice I use the word operand, not number in that instance, because of this. There's 2 operands and an operator. This needs to be treated, it's an expression, right? So it needs to be treated as an operand. So what we're doing is we're making that little list. This is why I'm going to need to have some recursive like flattening of list, which I couldn't find any way not to do it. I'm adding this to the stack so that next time, when I'm doing this next time, it will be one thing, right? Because we want to consider it as one whole expression when doing the same thing of pop, pop, and then pushing it back. But then at the end, what do I use? Just use the stack? Is that what I meant? Yeah, so we then recursively flatten the stack. Okay, so this is, let me show you a little demo of this. Is this working? Right, I've got my string, which is quite complicated, but then I split it, I reverse it, I do the operator stacks and all that, and then pop, pop, append it as here, and there's a print of the stack, and then I've got this recursive flatten I'm going to go into in a minute. That also not working. No, all right, so we came in with this, and then in the stack, because of this thing, because we every time we identify something that needs to be evaluated, that is an expression that becomes an operand, we're gonna have nested lists within lists. That's why I've picked this kind of use case, because it does a lot of that kind of nesting. And then what we need to do is then flatten this back, because or in user input in RPN needs to be just a flat list that either has numbers, or in that instance I've messed up because I think I don't want int x, I just want x, right? Because the evaluate RPN expects the numbers, the operands, as strings, but that's fine. That's just that's a target clear specific problem, right? So we're here, right? So here it's not quite return out, because in here out is nothing to start with, so I'm not kind of, if we need out as much as thing. Let me, I think, put a breakpoint here and then just like run it in debug so you can see what I'm talking about. This, oh sorry, I've got, this is not just need to make that syntactically valid by adding a little pass in here so that the linter won't break. And run and debug, I've got a breakpoint, just one before we exit that. I've got two actually, 48. Yeah, so here and there. So in this one with my old friend minus plus 8 3,2. Assuming prefix, yeah, we're here. Or is it broken? List object is not callable. What am I doing? Just a kind of, I'm not used to the whole streaming when you kind of speak at the same time. I mean, good when you're playing video games, but when you're actually coding, you kind of need to focus a minimum. So I want to append, not just the append, meaning you push it into the stack. Right, back in here. Random game, no, not random game, the training game with my minus plus 8 3 2. Cool. So this is right. This is S. S contains 832 as an item, then 2, and then right 832, then 2, then minus 2 as a thing. So what I want to do is I want to go through a list like this and return just a flat list, which means that if I can't remember I did that. Did I like use a type comparison? So for so I was so smug, I was like, oh, I've done it once, you know, kind of, but I don't need to go look at it, I can redo it live for the element for X in nested list. This is where I think I do need an output classic and about something, and and return out at the end. So we know it's going to be something like this. For each element of nested list, if the type of X is equal to the type of, say the empty list, then I want to extend out by the flattened, so X is a list, which itself might be nested, right? So I'm calling recursive flatten, so I'm extending, no, I'm doing out dot extend, and I'm extending it by the return value of recursive flatten called passing X, the sublist, as an argument. So this is gonna flatten. They might call the kind of, you know, down a recursive stack several times, but what comes out of it is a flat list, and I extend out. I extend as in I extend the output list by this. Else here. So if it's not, that's a, in other words, it's going to be a string. It doesn't really matter, but it's not a list, and we just need to add it to out. So out.append X. And for the magic of recursion, I just wanted to do some recursion. Sorry, I like recursion. For the magic of recursion, then we can hopefully, so out is equal to, I'm gonna do it in line. Return is, so return, like print used to be like this. Return is not a function, it's a statement, but it will work with the brackets. You don't have to worry about this. But here we want to recursive flatten of nested, nested of S, of the stack. Oh, and I mean, I could already pause here. That's cool. Oh, actually, this will work. Look at this, and then I just run it. Out is not defined in convert out is not, oh, because yeah, no, so I can't, it's get it loaded in memory. I can't change the code live. I can add a breakpoint weirdly, but I can't like change the code. As I'm debugging it, that'd be a bit cheating. All right, the training game once again with minus plus 832. Assuming prefix, S is the stack, we're about to return the recursive flatten of the stack. I'm just going to put another breakpoint here so I can see it in action, catch it there, and then S is not defined, but out is. Oh, sorry, that's the nesting. So this is, we're returning, we're inside itself, right? It's called it once. Output is nothing, and then output, the nested list is this one, and X is this one, and then inside this we get this. So we've just done that, we return it out. And then we return it out of this, and then we return it out of this, and now look at this, out is 83 plus 2 minus, which is exactly what I want for a RPN expression that captures the 9. So let's keep that was working, and I've got one, scored one, and got this. Right, okay, I'm quite happy with myself. So can I do like a plus, ooh, divide, is that, has it, yeah, the precedence 512, oh, okay, I might need to, I'm not go too crazy, plus, divide, 512, 8, 2, 2. So that's the classic one that gives us 68 by doing 64 plus 2 plus 2. Oh gosh, I'm gonna work my full of those as well. So like, oh yeah, there's only one of them, but because of recursion, it's going to get called a gazillion times. I don't want it. Cool, look at that, score this and capture that. So happy with myself, it worked. So we now have a target clear code that will accept any kind of format of expression. So let me show you what I mean by this. Our expression can be prefix, infix, or postfix. We're detecting this with that. For if it's in postfix already, we just have to split it. Okay, we're not doing the validation. That's fine. That could be any old garbage. Could have letters in here, as long as it has commas and ends with an operator, or for prefix starts with an operator. The convert prefix to RPN. I should really be more diligent in putting chapters on my videos, because there's no point doing a recap if people can't access it. But the convert prefix to RPN, that's where the magic happens. We've gone over this. I just wanted to go over this because it's a point of concept. you know, that's on the spec and it's important. So you turn it, you take your string, you turn it into a list, you reverse the list, which you can do with dot reverse or with the -1 notation. Then you go over those, and if it's an operand, push it onto the stack. If it's an operator, you pop the last two things on the stack, and then you have a sort of sub-expression, and you push that as an operand to the stack. So effectively, you're building the output in the stack, and then at the end, you need to recursively flatten the thing. So essentially, you're just removing all of the brackets, inner brackets, so that it's kind of a flat list of operands and operators. Okay, can we do question 19, the super solver, in the remaining 25 minutes? That's a shame, because I just said I would stop at 12. I think I'm feeling hot like Pol Pot. I'm going to regret this. All the possible combinations of numbers allowed. All of them! All right. Let's get this show on the roadium. Z19.py, the super solver. All right. So where do I, it needs to be in line. It needs to be, sorry, how do we test this? Enter the display prompt. Prompt the user if you like switch operation is turned. If selected, the okay, right. Okay. Or if I'm literally only going to, at this stage, I'm only going to look at the first letter. So you could say help, it will work. So if the first letter of user input gets to an upper thing is a capital H, I am going to, is an equal capital H. Let's not have the energy of the live streaming get the better of some degree of conscientiousness in coding. All over the place. Oh yeah, I got some coffee in here. Okay, so if the user wants some help, they've told us, I mean, they've kind of spec'd it. Generate evaluations. Calculates to operate as described. What is described is display a list of expressions. So generate evaluation should print it. It should do the printing itself as well, right? So just going to call generate, to which we pass targets. Obviously, we always need to pass targets and numbers allowed. Okay, so this is where I'm going to need to maybe, you can run it, but I can import it if I find, I'm just not put in yet, whatever, right? Evaluations, targets, available numbers. That's how I've called it, right? I'm not, yeah, okay, generate evaluations, number, and this should do the printing as well. So tries all the possible expressions. Well, generate, okay, well, let's actually sketch it. This is good practice, particularly for section B. Maybe, as I said, I need to, okay, I promise, next week we're doing only section B. You got it. But in section B in particular, but it's good to just sketch, right? You can start with pencil before you put in the ink. So I'm going to generate all possible expressions. This is going to be, I don't know if you do combinatorials and permutations in further maths, if it was in maths at all. Unfortunately, for some reason, they will basically teach you physics, like mechanics, because that's, I don't know, we did it differently in France back in my day. Anyway, generate all possible expressions and then evaluate for targetness. Evaluate them for targetness and then print the evaluations, the target evaluation. Okay, generate all possible. I just want to, like, okay, I'm just going to say print hello. Oh, hi. Because I just want to check if I open a Python console and I import this is not gonna work, is it? Just, and then if I do, so import Z19 will load the file but not run it. So that's how you know it's not calling the main function. That's what, but I've got all of, they should have all of the file. Generator exit. Generator exit. What is generator exit? And why is the? It's not defined. I've imported Z19. Import Z19.py? No, that's not going to work. But import Z19 and can I do this? Yeah, right. So in this package, you have all of that stuff, but I don't think generate evaluations. Oh, it's evaluations plural. Okay. So if I do generate, oh no, because it's Z19, so I need to access it like this, right? Z19 dot, you know what? From Z19 import generate evaluations. So if I do generate evaluations, needs 2 arguments but doesn't use them, so I'm just going to pass none. Hello. So point is, what I have here, I don't want to run the whole code. I'm going to be debugging this, what's going to be a expletive redacted of a, it's going to be, yeah, it's going to be tricky, a hairy, a fuzzy, going to have nuts in it. So I don't want to have to run the whole code to test this, so I can test it in the console. So generate all the possible expression, that's already an interesting problem. So there are 5 ways of picking the first number times 4 ways of picking the second number. That's 20 pairs of numbers multiplied by 4 operators. There's 82 2 operators expression. Let's start with those. So okay. So let's one operand expression. So x plus 2 expressions. Let's tap this with 2 numbers. Right. Expressions is the empty list. Fine, be consistent with the styling, although I absolutely loathe it. And then 4 A in available numbers, for B in available numbers, for O in, so this is our good friend, the list of available operators, which plus minus star, no, just it's getting confused, and slash for division, right? And then we just need to generate them all. So we're gonna append to expression. The good news is we're gonna, like, you know, in no brackets, infix. So we're gonna generate them exactly as the user would type them. This is question, this is question ZigZag 19, which is doing a full solver, like literally, this is the actual brute force, like trying all of the possible combinations of numbers allowed and standard operators in expression, which is crazy. So my first instinct, right, if we just look at the expression with 2 numbers, we're going to make every possible combination like this and append. So I'm just appending a string is my point, right? We append str of A. Okay, available numbers, just like real quick, is this, correct? Fill numbers. Right, it's in actual numbers, it's not strings, right? We have actual integers in there. So we need to cast them to a string in here. We need to plus, this is the string concatenation here, plus the operand, plus the str of b. Now, everything here should be valid of sort, but you know, some of those might not evaluate to whatever. We can't, I mean, we could use a Python eval, but this is kind of what they want us to be doing. But let's start with this, right? And then, you know what, I'm just going to maybe put a little cheeky print. You know, I use a debugger, but I'm a human dev as well, right? So you just put a print in your code and you see what comes out. So we're gonna, you know what? Let's just have an intermediate variable and call it x is equal to this little concatenated strings, and we're gonna print it. And we are also going to then simply append it here. Save this. Get back to my so it's numbers allowed as this available numbers is the second one. So if I'm going to use the one from the training game, which are those. Wow, that has spectacularly not worked. Now, I don't know if the problem is if I'm running it from here without the full debug, right? Like when you run it in debug mode, you need to kind of, you know, it's a whole like command. That's just running it, right? But some, you know, like that's not, I don't have access to the debugger here, so I might need to kind of like, you know, just, it's shameful. Maybe, okay. Actually, I'm going to do it the other way around because that way, I'm not going to even need to print the expression. So if I actually go operand, then operator A, then O, no, here, then B, and then that's the expression, which allows me to also put one of those lines, like this one here. Oops. Print O here, and in here, print B, like this, and yeah, I guess. Okay, maybe I need to kind of reload it correctly as well. So maybe here I don't want this. I want actually line break at the end of this. So save this, exit that. Maybe it's not that. It's not more simple. Oh, what's going on here? So 2 plus 2, right? That should have worked. And there's this all. Why is this coming up? I don't really get it. Okay, let's print the full. I know. Hold on. No, I can't. This should return. This should return expressions. Let's return expressions and save it. Get out of here. Get back in there. Load it, and then here actually say E is equal to this. Hello, Pixizor. Cool name. Right, and if I say E, this is my list of expression. 2 plus 2, 2 plus 3, 2 plus 2, 2 plus 2. Oh, there's 2 2's in there. Yeah, we could probably deduplicate a bunch of those. I mean, not if it's actually worth. They've thrown us a curveball with having 2 of them. I could simplify this already, but I think I've got all of the expressions there. Then evaluate for targetness. So I'll start with like the simple, you know, A plus B, or you know, two operands, one operator, infix expressions, and then see what I can work with this. So now for E in expressions, expressions colon try yeah, we're going to try to say postfix x convert to RPN E and like there's a is target, like check is, this is such a dumb name as well, but this is the one actually like does the core functionality of the game. It's called check if user input evaluation is a target. Very well, and it takes the score and all of that jazz. All right, let's just have a look ourselves. It's like literally you count, and if you find it in here, all right, but this needs to change the target list. That's why you're going over the target. We can just use an in, right? So in here, we convert it to RPN, and then we call the result evaluate RPN of the postfix. Postfix and RPN is the same thing. Actually, I might, you know what? Let's be consistent as well. The RPN expression is converted to RPN, the infix expression, one of the many we've generated. We then get the result. Now I'm wrapping this into a try block because sorry, wait. Yes, I need to accept closing now because I'm not sure this is going to work. So except we continue, which means skip the rest of the thing because we don't have a result, we don't have anything. If result, so if it's not an int, I can rule out. So I can rule out anything that's negative or zero, and anything that's not an integer. So for the integer check, you get one in here, right? This is this. Kind of ugly, if I'm honest. But you know what, who am I to judge? So it's like you cast it to a float minus the floor of the float, and if that's equal to 0, right? Seriously, fine. I'm not going to question this, just going to copy it because it's an exam day, I'm in a hurry, whatever, right? I've lost it, it was there. If you have such a floor, it's going to be there. Yeah, okay. That's, I do check it's an integer, which is you subtract, if you subtract from it the floor, that is the kind of truncated version of the number, the integer below it, the result, the difference is 0 in float. So if except of S0, we're gonna use result, right? So if result, this has, I got no idea what I'm doing. This, I'm sure this is gonna, yeah, I know, Riyad, but like I'm gonna show up the whole concept, right? So first it's generating expression, then it's like checking they evaluate this, because once I've got the bottom of this with the printing is gonna be the hard part. Then I can start making the way we get to an expression list fancier and have more expressions. But the point is, I want to get to an expression list so I can see how we check it. Also, I'm not looking forward to having to do the. I guess it's only kind of like 4 cases potentially, depending on, but like there's going to be a lot of copying and pasting, and if you want to abstract it away, it's kind of a little bit fuzzier. So just like starting simple, and then we'll think. So if the result first needs to be, I mean, it's going to be larger than 0. So let's say larger or equal, but doesn't, 0 is not on in here. And this, if. Maybe I want to do the printing. Maybe the printing is going to be in the checking, actually, right? So if result is in result targets, if results in targets, then we're just like going to print E. Was it E plus equal, and then I guess result. I'm struggling to believe this, but it is possible. Okay, is this, again, breakpoint I'm not going to use. We generate all the expression of all, as we had as found out. I mean, I couldn't predict questions, but like there's a 7x7 box, you know, there's a trace table. Usually they'll give you an algorithm, right? Section A has nothing to do with the code, so you can't know what the trace table is going to be about. There's a trace table, but there's a trace table every year, right? And like predicting a question is not, you know, like how is this information going to help you? You're going to revise only this thing? It's a trace. You need to, we can kind of look at trace table because there's a couple of problems that will trip up students every year. But I can't really predict anything more than you're going to have a trace and it's worth however many mark, right? But that's kind of the case every year. Could be assembly trace, or could be just a regular trace in kind of AQA pseudocode, which, I mean, neither is particularly something to look forward to. Right, so we're doing the printing in here. Am I returning expression? I'm going to return the expression just for the sake of it. Save this, get out of here. Okay, I might want to deduplicate the list as well, but that might be a different question. It's and then. Ooh. Oh, because target is none here. Sorry, yeah, that's my bad. So for targets, I'm gonna want the training game or whatever. Like, come on, this one. That's my target list. What makes you think that's what I've not really had a look at the EAD beyond kind of the first time I opened it. What makes you think it's a Dijkstra trace? Wasn't there a Dijkstra next year? Tack. Paste it in here. Okay. Oh, right. Oh, look at this. Right. So, except there's a lot of garbage because I'm printing way too much, but it looks like I've got my... so not this one. So I only want to print the one that actually evaluates. So Python, get back here, import my generate evaluations. Is that it? Well, that's better than nothing, I guess, right? But you know, we're not allowed to. Oh, except that's not a valid one, right? Because there's only one print, and you're not allowed to use them once. To use them more than once. So in here, you're gonna need to have a if B is equal to A, you skip it. So you won't generate strings where A is equal to B accidentally because you're not allowed to use the same number twice. Okay, let's do it again. Python and reload. Maybe I don't need to reload the full Python stuff. So actually there's none. It seems that that's a bit awkward. All right, let's say I had, instead of 9, let's say I had, whatever, let's say I get 16 here, right? I'm sure I should find 16. Okay, it's fine. Wait, because there's 2 2s, right? So technically there's like 4 ways of doing a 16. I guess I need to find if I've got the CID somewhere. It's hijacking. Let me just finish this, right? So we've got this, except that the training data is not great for this. So clearly we need to go deeper. What I don't like about this is that we kind of Now, here's an interesting thing, is that every, say, 3 operand expression starts with a valid 2 operand expression, right? So what we have here, I'm not going to rename it. Well, I'm going to rename it. No, I'm not going to rename it because that's expressions for what's now. And then, okay, so no, actually, I am going to rename it. I'm going to rename it here and here. Well, actually, no, sorry. Okay, fine. Two num exps. the two numbers expression, right? And we're putting it in two num x. Right, so we've got the expressions with two numbers. Now, from this, so this was 20 times 4, so that's 80. For each of those 80 ones, you can combine them with, so there's only going to be 3 numbers remaining. We don't know which one they are, but they're here. The expression's a list, the expression's a string. The expression's a string, that's just annoying. Yeah, maybe not as a string actually, maybe as a... Let's have it as a list because we keep... because we need to check, right? So we're gonna have some... I'm coming in, I've got a list of 80 percentable two numbers expression. I want to use this to start building 3 number expressions, which I use by taking each of those, and each of those can have like 4 operators, and then 3 possible, because there's only 3 numbers, we've used 2 already. This is, at least that part gets simpler. So to know which one we've used, I need to look whether the number as I iterate is present in the expression, which is better in a list than a string, because if you use a string, that's all fine and good and you can use in, no problem, except if you have a number that's getting more than 1 digit, because say 512, 2 is going to be in the string, but 2 might not be in the actual expression. So I'm gonna keep my expressions as lists until the very end, until I get them all, and then we can have something where, you know, kind of for reading expressions, we're gonna flatten it to a, I guess, joining into a string or converting back, but I'm going to do that. Right. So for now, I've got like, right, build the 3 expressions, build the 3 number expressions from the 2 number ones. Number ones. So for E, because that's already an expression, right? In the 2 num x, and then for O in yep. You know what? I might. Yeah, I'll use. No, actually, fine. Let's be at least a little bit clean, and define operators once here, and then test for presence in operators. So for each of the O in iterator operators, for each of those, and then for, I guess, let's call it C, but, well, I guess we could call it C, right? Because we know where we are, there's only a free one. I'll see whether there's a way of abstracting this away as a general case, but let's work at it. And, you know, there's only 2 more types of expression after that. So for C in the available numbers, if C is in expression, we continue. So skip any C that's already present in the 2 digit, 2 operands, 2 whatever, right? Like the first layer of complexity, the basic expressions, and then if we don't continue, then we also need to build do I want to, fine, let's do 3. I feel like there's a better way to do this, but I don't feel comfortable appending to a list when I'm iterating on it, but ultimately you want those to end up in the same one. Well, yes and no, because we don't want to have the 2 and the 3 mix when we're going to build the 4, because the 4 numbers, right? There's the 5th number one that's possible as well, because we don't want to mix them up, because we, you know, build it, that this is where we are. We build a 3 number expressions, of which we had none yet, right? So we're gonna, the expression is equal to, so I'm gonna do it flat, so there's gonna be E0, right? So no, it's gonna be extend. It's gonna be X plus, because you can concatenate list, plus OC, and then I could now 3 num x append x. Now I feel like we can generalize this, because then we just get an adder kind of thing with, but Because remember, technically, just an operand, just a number is an expression, and that's why ultimately you kind of start with the numbers, and then you would have actually 4 layers of that. But it's just okay. So we've got the free. Shall we have a look if it, works? Free numX, and because I don't have expressions yet, I'm going to. I'm just going to like literally comment out. Oh no, actually, yeah, comment out all of this stuff. Save it, get back to my... Well, let's see if I can just resource it again. Yeah, so that's why I need to kill Python, because if you re-import, it say I've already got in the namespace, I don't need to import it a fresh one, and there might be a false flag or something, but... Whoa! Yeah, there's a bit of a problem here. Why is there so many zeros? That's the weird thing. Oh, I just... Oh, right, because it's not 0C, it's O. No, it's OC. But why is this a flat list? It shouldn't be a flat list. I'm not liking this at all. Okay, that's kind of like more like what I expect. Predefine 2. Okay, free numX is nothing. And then we append x. Oh, and x is no, x is not x, peps is e. Sorry, that's the problem. And you know what? I'm just gonna put it here. I think simplify greatly. Well, save one line. Same ditto here. Okay, we're back. Testing. Right. Yes. Okay. I'm digging this. That's looking pretty cool. Right. So I've got all of the free number expression. All right. So let's literally just do like this again, except this one here is in fact. Oh, okay. Connect this. This in fact. So those three are for numexps, and this one should be from the free numexps. Am I going to print it? Maybe I'll print the first. I'm just going to print the first element, so just to see I'm doing something. And then the 5 num. Now the 5 numx. No, because there's no way. There's only one number, but you still need to iterate all of the available one. But most of them are going to be in the previous expression, so no dice, no doi. So let's go here and then boom, 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 boom. This was Venga Boys tracks when I was like 15 years old. That was like the hot. Oh, I'm getting confused. 5 number. Can you believe that? No, that's the end. I think that we're not going 5 numexps, and this 5 numx is built from the 4 numx. There's no way this will work. He says running it, but sometimes you get a. That's because there's none. So it's built a correct 5 numexp, and it can't. Let's see if let's not access it the index, but instead just gonna write up straight up, print it. There's nothing in here. Why is it like 1, 2, 3, 4? Okay. Right. So I've done all of this stuff so we can, because the 5th number is another 2. That's the problem here. And the problem I have is that, okay, so it can't distinguish between the 2s, and it thinks that it can't build the next one because it's got this. But, right, let's just like, well, it's not specifically here, but like I'll just put like, to do deal with duplicates numbers better. You could, I guess you could pop. Yeah, what you would do is you would pop them as you. I mean, I can probably nest this, right? Because we're just in the middle of this. We get the 2num expression. But I would have to kind of like C and D. I mean, that would work. I don't know, whatever. Right. So let's not worry about this. Let's look at the evaluation then. So I have my 4, my 6, my 2, my 3, my 4, my 5. And I want them to be in a single list of expression, which, okay. Right, so let's say that, let's say we get the big expressions list, expressions, and low, because it's not defined, that's why I'm defining it. I'm defining it as the 2 nums plus the 3 nums plus the 4 nums. Not future warning, plus the 5 num x. Now, the thing I've changed as well is we have them now as lists rather than strings. So let's go really quick to Python. The problem I have is, let's say something like this. E is equal to that, and I want this as a string. So this is where you would do this. Okay, so map string to it. No, just this comprehension. So str of x for x in E. Now I've got as a list of strings, and then I can do join E. Right, that's my expression. So I want for before I try and evaluate them, right? Because this needs to be as user input, right? So that needs to be a string. So I want E becomes equal to nothing joining the list of, not E itself, but of the string, casting to a string the elements x for each element x in the list E, because E is a list as an expression, and then we do the conversion to that. I continue, check that it's positive and an integer, and then if it's in target, we print it. Okay, well, I mean, it's like bang on, I went bang on time, so I'm kind of like happy. I'm going to stop here if it works, and I'm going to be stuck there all afternoon if it doesn't. Okay, very excited. Generate evaluations, and using the, so we're not gonna have any 5 expressions because we're using the demo target like training game, which has 2 2s, which is annoying, but hey. So it's not picked up on the 512 divide 2 and so on. But like I'm not mad about this. Sorry, I'm saying this in the American way, which is I'm not unhappy about this, because when you say mad, the British way of mad is like I'm really enthused about this. When you say I'm not mad about this, when you say I'm keen, whatever. Right. So I think this works good enough. This works enough that we can actually plug it, which we already have, right, in our play game, which was there. Yeah, right here, right? Or help, and if you have help, you generate evaluation. Generating the evaluation literally just prints it to the console. Maybe I'm gonna remove this one, and this one, and this one, and we're not printing the 2 numex anyway. All the prints in the middle. Tidy this a little bit. Okay, yeah, cool. And then there's the main, right? Let's see if it works, which would frankly astound me, but sometimes I'm going to use a random one because of that thing. So if I do halves, whoa, hello, there's a whole bunch. This is why they tell you if you find a way of doing it once, then don't duplicate. I was like, well, we've done all of this effort to find them. Why would we not display the duplicates? Because there's many ways to skin this cat. So let's do it as they ask, which was like without the duplicates. So how would we do that? With a found, probably. I could pop. No, because this actually gets targets itself. So start changing targets. It changes the list I've passed to it. I'm just going to do found. Sorry, found with a capital F. So the found thing, so if it is, we're going to print it, and we are going to, if, so it's in target, but it's not in found, and if it's in target, but it's not in found, I'm going to, whoa, append, result. All right. Random game. Look at this, boom. All right, I'm digging this. Not bad. Yeah, so I mean, I thought like solver, we want to do something with a heuristic, something a bit more, a bit smarter. But that even doing the full thing, I get duplicates here, so that's not the thing. That does return fast enough. Okay, are we gonna have a look at better deduplication so we can reach the 5 number expression? Yeah, I think I could probably rewrite this so that we append them to. Okay. Yeah, I can like this is gonna be ugly as, but here we are. All right. No, so I need another one for O. That overwrites it, right? But I don't want to mess it up because it might not be. Yeah, for O2 in operators, and then we pick a third number if it's equals to the first two. We think otherwise we. So I'm not going to use two numbers expression. I'm going to do straight to expressions, which I have. Do I still have an empty list somewhere? No, yeah, I need to initialize it as empty first. Oh, well, this one, really. Okay, so we've appended the first 2-digit expression, and then we actually start building all of the 3s possible from this, and then all of the 4s, etc. So if it's like that, we continue. Otherwise, we will expressions.append, and it's A, comma, O, comma, B, comma, O2, comma, C, helpful. And then once we've done this, so nested in there, we're gonna go for O3 in operators, for D in available numbers. If D, I'm gonna start using an in, right? D is in A, B, C, style it with spaces because it's neater. We continue, so next iteration of the loop. Otherwise, we are going to append to expressions. No expression. Expressions dot append. So now it's A, O, B. I'm not putting the spaces at this stage. I don't give. I've run out of Fs. O3 and D, cool. And N, 4 in operators, for E in. So we don't know which one it is the problem. There's only one left, right? And then if E in A, B, C, D, D, we again continue. Otherwise, we are going to add append to my expression list A, comma, O, comma, B, comma, O2, comma, C, comma, O3, comma, D, comma, O4, comma, E, and I've messed up a couple of commas. And that's tight. So we don't need any of the 3, 4, and 5 anymore, nor this, because that's expressions. And we've built expressions like in a set of like ugly nested loops, but like that doesn't make, this looks like massive complexity, but ultimately those are fairly small possibility space for a computer. Now is this even running? Do I have to? Okay, so home. I'm alone. Is that it? 3 plus 8 minus. Oh, but I've put the training game. That's why. All right, fine. Let's do this one. What? There's nothing I can do. Oh, helpful dock you a point, right? Because it counts like an iteration. Why is there nothing I can do? Oh, because it's always the same numbers. Yeah, so you can have 512 divide 2 divide 3. No, can't divide by 3. Right, fine. Let's run it again, but not in training mode. Help. Yeah, there's plenty of stuff to be done. So that works. So sorry, it was just checking if this was the same thing, and it works. Okay, so diff for task number 19. Compare with selected, zoom out a little bit, remove this. All right, so what we have now is just support the help. So this time, you've seen me do user input.upper. You can even do better and just like check the first letter, because that way that will accept everything. And then we have all of the new functionality into a new function. So this will do checking, generating the expression, checking them, and then printing the actual, hints. And this is the magnum opus of nested. Literally you try them one by one, and there's no there's no heuristic. That's the brute force, right? The couple of key points is you can't use duplicates, but so you continue if they match any of the other. So pretty quickly I'm using in to verify, and then you append. So if I had it could be interesting to put a breakpoint. If you put a breakpoint, you will see it will first generate the first expression with 2 digits, and then like all of the 3. So we've established there's like times 4 times 3, so times 12. So there's gonna be like 12 free number digits, 3 operands expression. Then there's another 4 times 2, 8. For each of those, there's 8 so each of the 12 threes, there's 8 of the 4s, and then for each of those 8 of the 4s, there's only actually 1 of the 5. So like you can only do the remaining one. It forces the last element, last operand, and you're done. So yeah, and then this builds the expressions list, which is the first pass. I mean, I guess you could evaluate as you go along, but I find it needed to separate, and this has allowed me to verify my evaluation problem only with the 2 operands, expressions generated and separated it. But so to try it, we have a found thing to make sure we don't display duplicates, and then for each of the expression we convert it to a string, convert it to RPN, convert it to a result. I've got a big try except, so that if it doesn't work, you just kind of continue along. I should maybe could maybe catch something, print something, see how often it fails, but it will fail. I mean, I don't even want to know. And crucially, we can save ourselves some checks. The results need to be positive. It needs to be an integer. And then if it's in target and we've not found it yet, we just kind of print, oh, this expression equals this result. And we append that to found to make sure we don't do the duplicates. And this is how you do task 19. So start a random game, helper suggestions, so the evaluation could be used. I mean, this is pretty, it's pretty cool. I mean, I feel like the accepting prefix expression was just like slightly niftier anyway. So, I'm a bit lower than I wished. Okay. I've got one of those raisy desks, standing electric. Right, thank you very much for watching. I will be there next Sunday, probably same time. I think like 10-12 works better, like start earlier, but I do a 2-hour thing. Although I mean, I've got a PhD to do, but you know, it's for good cause. We'll get 3 more streams next week. Let's do some section B, and then yeah, I think that we can have a look at this Dijkstra thing. But I mean, it's basically you have to go by the idea. If you want me to kind of like do something on Dijkstra, we can do something on Dijkstra. It's a nice one. I feel it's really fun to do it in code, frankly. But yeah, whatever. So. Thank you, and I guess goodbye.